right, so right triangle trig. So this is a way to help you remember. So you can think of it as SOHCAHTOA, or some old horse caught another horse taking oats away. I don't know. It's whatever way you want to remember. Okay, so SOHCAHTOA. We'll go over what this means in a second once you glue this into your notebooks. When we are talking about right triangle trig, you use SOHCAHTOA to help you remember what to do. Sine, cosine, and tangent are all trig functions that look a little, so they're like wave functions like this for sine and cosine, and then tangent is like that, okay? So you'll learn a lot more about what those actually are and what they mean, but what we're using them right now is to solve triangles. We can use right triangle trig. Okay, so when you have a right triangle, let's say that this is your angle that you're using, okay? The one across from the angle is called the opposite. The one that's kind of attached is the adjacent, and then the hypotenuse is always the hypotenuse, okay? Because if you use this angle right here, what would that be? Is it still adjacent or is it opposite now? Yeah, because if you're using this angle, that would be opposite, and this one would be adjacent, okay? Okay, so the sine function, if we're looking at this theta or this angle, so when we don't actually know the angle itself, it's called a theta. When we're using the sine, we're going to be using the opposite, so sine equals the opposite over the hypotenuse. So if we're doing sine of this one, we would do opposite over hypotenuse, sorry, okay? And then cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. So SOHCAHTOA helps you remember what goes with what. And then we'll start solving stuff. And you can use, even though it's cosine, these are like the shortened versions. You don't have to say tangent. You can just, in your calculator, it's tan. So you can be using that. Okay? It's sine.
Well, like in the calculator.
Right, but it's sine, and there is sine, and there is cosine, and there is tangent. They're all in your calculator, and we're going to learn today and tomorrow how to use it and where to find it.
Does that be a sine?
It needs to be, well, it depends on your calculator. We'll go through them all. Okay, so let's actually try this. So we are going to be finding a bunch of different stuff. This is going to be your example, so I would draw this example out because this is the one that we're going to be doing as your example. So when it says find sine of A equals, who can remind me what sine is? Opposite over hypotenuse. SOHCAHTOA. It's just how you can remember it. It's just like right sine is opposite over hypotenuse. So. Okay? So we're using A. So what would sine? What's opposite of angle A? 5. And then what's the hypotenuse?
10.
So that would equal 1/2. Okay? 1/2. So sine of A equals 1/2. Okay, it wants us to find the cosine of A. What would the cosine of A be? Adjacent. Which one's adjacent? 5 root 3. 5 root 3 over 10, which would be, which would be what?
0.5.
You can leave it as a fraction. Root 3 over 2. Okay? And then tangent of A. So tangent of A is opposite over adjacent. So what's opposite? 5. What's adjacent? 5 root 3. So 5 over 5 root 3. What can I do with the 5s? Cancel. Do I have to get rid of the root 3 on the bottom?
Yeah.
So So times by root 3 over root 3, so we get root 3 over 3. Okay, that was all of the operations with A, but we also want to do it, we want to find it with B. Okay, so what would sine of B be equal to? Opposite, so 5 root 3 over 10. So opposite, because opposite's different this time for the next one. So 5 root 3 over 10 is equal to root 3 over 2. And then what about the cosine of B? Adjacent would be 5 hypotenuse, 5 over 10, which can reduce to 1/2. Awesome. And then the tangent of B, opposite, 5 root 3 over 5. What can we do with the 5s? Cancel. So tangent of B is just root 3. Okay. It's not bad, right? Okay. So give this a try. It gets a little harder. Awesome. Great job. So because we're doing sine of A, the opposite is 12, the hypotenuse is 20, and then you got to reduce it. Okay, give this one a try. Cosine of A. Awesome. Great.
Awesome. No.
Tangent of A.
Ready?
Awesome. Crushing it. Okay, now we get a little harder. We're doing the same thing, it's just a little bit different. So, this time we don't actually know all of the sides, but we know an angle. So we know that we need to find x and round to the nearest 10. We're still using SOHCAHTOA. So SOHCAHTOA really helps us solve triangles when we don't know a certain side. This you wouldn't have been able to solve without what we know right now because we don't have enough. Okay, so we know this angle right here. We've got that and that. So which trig function do you think we're going to use? Ryan, what do you think?
Opposite and hypotenuse. No, it's tangent.
It's not the hypotenuse this time. Because which one's the hypotenuse? How do I know that's the hypotenuse? It's across from the right angle. Okay, so we know that's the hypotenuse. So we're actually using opposite and adjacent. So we are going to be using the tangent function. Okay, because we have opposite and adjacent. So tangent of 25, so the degrees goes with the sine itself, is equal to what? Opposite over adjacent. Okay? So the tangent of 25 is equal to x over 18. How am I going to solve for x? How do I get x by itself here? So 18 tangent of 25. Now's the time that we need to practice and find this on a calculator. We need to find tangent of 25. So get your calculator. We do 18 tangent of 25. You get, oh, I'm in the wrong mode. If you ever end up with negatives, you're in the wrong mode.
Change the mode.
I'll show you how to do that in a minute. Well, it depends on your calculator. So 18 tangent of 25 is 8.39. We can round to the nearest 10, so what's that? 8.4. So this side would be 8.4. Could I then solve for that side? Yeah, could use the Pythagorean theorem, or you can use your trig function to solve. Either way. Okay, let's try another one. So this time, we're using 70, and we have this and that one. So what do we have? We have the adjacent and the hypotenuse. So what are we going to be using? So we're going to be doing cosine this time. Cosine of 70 equals, what's the adjacent? 15. 15, and what's the hypotenuse? X. This one you have to do a little bit different. How are we going to solve for x this time? Multiply x. So then we have x cosine of 70 equals 15. It's not just divide by 70. What do we have to divide by? Cosine of 70.
Then it would be x equals 15 cosine 70.
Not 15 cosine 70. 15 divided by cosine of 70. So that's just the algebra, right? Imagine that this is just the number. We have to multiply x and then divide. So then when we do that, 15 divided by cosine of 70, what you guys get? 43.9 if we round to the nearest 10. Yep. Let's give it some tries. Oh, not yet. Just kidding. Okay. So, the last thing with this is that if you need to find the angle measure, you are going to be using the inverse function on your graph. So you guys, the inverse function is the sine to the -1, cosine, tangent. That's what's called the inverse. Okay? Before, when we knew the degree, you could use the regular function because you already knew the degree. When we are trying to find an angle, you use the inverse function. Okay? So, we are trying to find angle P. I don't know why I did a circle like that. We want to find that theta. That's an angle. Okay? We want to find angle P. What do we have information-wise? Adjacent and hypotenuse, which means we're going to be using cosine. Now, we don't know what theta is this time. So we can't plug it in like that. So what we do is we do cosine inverse of the adjacent over the hypotenuse.
How do you get cosine -1?
So on your calculator, I'll help you in a second. Let me put it up. 13 divided by 19.
No, I did get it.
So we get 46.8 degrees. So let's try to find these on our calculators. So the way I remember is to get the inside, you use the
Inverse.
Yay! Alright, let's give it a try. Give it a try. Okay, so yeah, you do have to be careful with this one.
Oh, do you? What?
I could have pushed the wrong button. Give it a second. Should I change 15 feet to inches? Why? But why should I change it to inches? Because it asks us to find the ramp off the ground to the nearest inch. So you might as well just change your first one to inches, and then you don't have to do anything in the background. How do I change 15 feet to inches? 15 times 12 is 180. So this is 180 inches. We decided that's what we're looking for, right? Okay, so we have 4.8. We have the opposite, we have the adjacent. So we can do tangent of 4.8 equals x over 180. So how am I going to get x by itself? Yeah, so times 180. So we get 180 tangent of 4.8 is 15.1. So 15.1 inches. Now, if you didn't change it in the beginning, you would have gotten 15 tangent of 4.8, which is 1.25, times that by 12 to turn it into inches. So then you'd still get it, okay? Because that one was tricky because it gave us feet and had to change it to inches. Try this. Well, there's 4 answered. Wait, do we have 5?
Remember the other Mumio?
Yeah, the other Mumio got it wrong. All right, so let's go over this one. we are trying to find D. That's our theta. We have opposite and hypotenuse. What do we use the opposite and hypotenuse? Sine. But we don't know theta, so we're going to use sine inverse of 16 over 23. Don't forget to hit the inverse sign. 16 divided by 23 is 44.1. Yeah, but we're rounding.
07920985.
Beautiful. Oh, this is for tomorrow, so we don't need to do that.